Hello everyone, Gene Nech here with Eurekademics, and today I'm going to cover graphing polar equations and converting to rectangular form so that you can ace your exam. Alright, here's what we're going to cover. We're going to cover what you already need to know, and these are the basics like the unit circle, and then we'll cover the equations that you need to know later, and we're going to go over graphing things like lines, which are theta equals, circles are r equals 1, 2, 3, 4, whatever, and then points are like in polar form would be like a w, b, x, whatever, and then it's given in a radius, comma, theta. So like you're going to figure out your theta, and then you're going to do a radius, and it could be negative. And then you're going to figure out how to graph polar form, and I call them petals. And the hardest part on the exam is probably going to be converting polar to rectangular form, but you'll be ready to tackle it. All right, here's the unit circle that you need to memorize and at least have ready for you to take this test. If you haven't memorized it, there's a pattern. So you start with 0, and then each quadrant has 3 ticks. 1, 2, 3, 1, 2, 3, 1, 2, 3. Sine of 0, 0, and then cosine is 1. Okay, so you start there, and then you kind of do this one. Okay, so at the top, cosine is 0, sine is 1. And then these three, this is what you have to memorize, they have a pattern. So everything is over 2, so you might as well just start your parentheses, everything's over 2, over 2, over 2, over 2. And then you go 1, 2, 3, 1, 2, 3, and then just put radicals on the 2 and 3 because one's special. And then you use like logic and common sense to figure out which ones go negative, but the values all stay the same. So you just, for the ticks, you just copy these values over here. And then, well, because cosine is x, so here just x is negative and the same values, but the sign is positive. Here, cosine and sine are negative. And then here, well, we have a positive cosine, so your cosine values are still positive, but we're down here, so the sine values are negative. Once you have the unit circle, you're ready. All right, let's jump into graphing lines. Graphing lines, you're going to be given a theta, and it can be any one of these ticks or spokes on the wheel. And it can be positive or negative. So our first case is theta is pi over 6. So you just find it on your unit circle, and then you draw a whole line going through pi over 6. There it is. Boom. If we had pi fourths, you would go to pi fourths and draw a line. If we had pi thirds, you would go to pi thirds and draw a line. If you had pi halves, you would go to pi halves and draw a line. You get the picture. All right, let's take a look at the case with negative numbers. So here, theta is negative 5 pi 6. So the way I would approach it, I would ask myself, if theta was positive, what would it look like? Well, if theta was positive on my unit circle, 5, 6, I would do a whole quadrant plus the third tick. I would get to the third tick. Well, if that was the positive direction, then you're going to do the same thing in the negative direction. So you're going to do one whole quadrant and then the third tick, which is at 7 pi 6. All that's saying is theta rotated 7 pi over 6 is the same thing as going negative 5 pi over 6. Okay, so we're at 7 pi over 6, that's the same thing in positive terms, and then you just go here and then graph it. So let me do another one that was confusing. Let's say we had negative 2 pi thirds, right? So you would ask yourself, how far would it be if it was in the positive direction? That would be one quadrant plus one tick. So then you do that in the negative direction, one quadrant plus one tick. So theta equals negative 2 pi thirds is the same thing as theta equals 4 pi thirds. So that's how you deal with negative thetas. You assume it's positive and then just kind of use symmetry and go the other way. So like, check this out. Like, let's say it was theta is negative 11 pi 6. That's like right here. So if positive 11 pi 6 would be like the whole thing, right? So negative 11 pi 6 would be like all the way back here. Starting to make sense, right? Okay, let's take it to the next level. Graphing circles. This is actually easier. So graphing circles, you'll be given r equals 1, 2, 3, 4. It could be negative, but with circles it doesn't matter because in the rectangular form, the r gets squared. And in polar form, negative 2 or positive 2, same thing. So you just graph the number on the circle because that represents radius. So when you see radius equals number, you're just kind of graphing it. A circle. The semi-challenging one is graphing a point because this one requires like very good spatial, like rotational imagination ability because you can have a negative theta or negative radius. So let's just work the standard. So like, let's say we had a positive theta and a positive radius. You just graph it like that, okay? So the angle tells us where we land on which tick, and then the radius tells us how far to go up that tick, for example. Like 1 circle, 2 circle, 3 circle, 4 circle, and so on. So here we go. We're going to graph W. W has a radius of -3, and a theta, the angle is at 5 pi fourths. Okay, so we got to figure out where 5 pi fourths is. There it is, 5 pi fourths. Now, because the radius is negative, we have to go back 3, not on the 5 pi fourths ray. Going back 3 would actually move you on the pi fourths tick. So we're going to go up 3 on the pi fourths tick because that is -3. So there's W. I found my pi fourths tick and I went 1, 2, 3. There it is, -3, 5 pi fourths. Because I rotated 5 pi fourths and I moved back from the center 1, 2, 3. Now you'll be asked to name it 2 or 3 other equivalent ways. So you can name this point all 4 ways. The first one's given. Okay, so let's look at this. The way I would approach it, I would say, well, if the radius was 3, let's get the low-hanging fruit, right? If the radius was 3, what tick was I on? +3. Okay, so I was on this tick, so then I call it +3 pi fourths. Isn't that the same in polar coordinates? W lives there. That's true. Okay, let's try the variation where we still have a negative radius, but we didn't come this way, we went the other way. So we have to land here, but with a negative, I believe, yes. Okay, so how do we get there? So you're like, okay, I need 5 pi fourths, and I'm going to go back 3. So 5 pi fourths positive this way. How do I get there the negative way? So here it is. 5 pi fourths was 1 whole quadrant and 2 ticks. The negative way would have been 1 whole quadrant and 2 ticks. That doesn't make sense. Why is it there? Oh, there we go. That makes sense. Okay. So I need to get here. So I need to do 1 quadrant. There it is. And 2 ticks. Are you with me? So 1 quadrant and 2 ticks is this. It's 3 pi fourths. That means I do that. But if I call it -3 pi fourths, that's how I land here. That's why I called it -3 pi fourths. Because 1 quadrant, 2 ticks is 3 pi fourths. 1 quadrant, 2 ticks is this. And I'm on the ray I need to be. And then I go back 3. And I named it. And then the positive version, the last one, so you have +3, but we're not going to rotate up. We're going to go home the negative way. So how do I get here going this way? How many ticks would that be? Right here. Yeah. Okay, so 1, 2, like that. Boom. So -7 pi fourths. So if I did +7 pi fourths, I'll go the whole thing and be here. But -7 pi fourths goes the whole thing and you're here. And that's how I got -7 pi fourths. Okay, so you go with the given one and then go with the easy hanging fruit and then find the other 2. And that's it. All 4 of these name that point. Graphing petals. Okay, it gets, this one's kind of fun actually if you know what you're doing. Okay, so signs are, if you like the simple one where you have like no number next to the theta and it's kind of basic. Signs are going to be circles going up or down, so on the y. And then cosines correspond to circles, positive circles or negative circles, okay? And then that number in front over here, this 5, that tells you actually the radius. Like remember when we were graphing amplitudes? So that gives away the peaks of the petals, 5. And see, this is a 4, so the peak of that petal is 4. And if it was negative, it'd go down to 4 here. And if this was -5, it'd go down to 5. And if this is 7, you would just be bigger as -7. Make sense? If it was negative. Positive 7's here. All right, let's get to the good stuff. Graphing petals. Okay, so we have a rule. This number in front of the theta gives it all away, and this number, the amplitude, tells us how long the petals technically go. Okay, and then you're allowed a graphing calculator, so your data set and table set will fill in the rest. But having a big picture really is going to help you speed this up for you. So if this number is odd, that's how many petals it is. So like in the last problem, because it's 1, you only have 1 petal or 1 loop. okay? If it's even, we double it, and that's how many petals you get. So because I have a 4, this results in 8 petals. 1, 2, 3, 4, 5, 6, 7, 8 petals because I doubled 4. So remember this rule. If it's odd, that's how many petals you get. If it's even, double it. All right, so this is what r sine 3 theta looks like. Because 1 is the amplitude, the furthest point on each petal is going to be 1. And then because it's odd, we just keep it 3. And the number is 3, so it's 3 petals. 1, 2, 3. And then go to your graphing calculator to figure out the points. But you know the furthest point is still going to be 1. If this was a 2, it would stretch to 2. This is what cosine looks like, r cosine 3 theta. Again, because it's odd, that's the number of petals. And because the amplitude is 1, it's the peak point of the petal is 1. And then memorize this rule. It will definitely help you, give you the big picture. So as you go to your graphing calculator and the data set, it all kind of makes sense as you're graphing it because you kind of understand where you're supposed to go. Now, converting between rectangular and polar coordinates. This can be tricky at first, but if you just kind of back up and understand why we created it, I think it'll help you. So you're probably really comfortable with the Pythagorean theorem by now. And this is where it all comes from. And if you took physics, you recognize that this component, your hypotenuse, acts as like the magnitude of the ray, and you can break them up into components from physics if you remember. And then this one would have been like hypotenuse times cosine theta, or hypotenuse times sine theta. If you don't know how I got that, you can derive it. So like SOHCAHTOA, right? Sine theta is y over r, and then you just solve for y. And then you get y is r sine theta, and the same thing for x. And then you should probably already, tangent theta, we're going to use this one. That's y over x, that's from SOHCAHTOA. And then this is the equation of a circle. R squared equals x squared plus y squared. And then if you had any numbers in parentheses in here, those would be like your horizontal and vertical shifts of the center of the circle. And then this represent, when you square root the r, you get the radius of the circle. So you're going to need to memorize this, and then these two. And you're going to manipulate the equations so you can make substitutions. So anytime you see an r squared, like if you were given r squared equals blah, 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 or r equals blah, 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 you can multiply everything by r to get it into r squared. When you see an r squared, substitute. And then once you have x squared and y squared, you're so much closer, that much closer to rectangular form, and so forth. All right, let's take a look at a real-life example. So we have r equals negative 3 sine theta. Okay, and then here are kind of the equations if you didn't write them down. So we have an r, okay, and then my first thought is, okay, well, I'd like to have an r squared so that I can produce the x squared, y squared relationship. So you just put parentheses and multiply everything by r. So r times r is r squared. And then when r hits this value, we're just going to stick it in here. So we call it negative 3r sine theta. Okay. So when you have r squared, you can go ahead and make this big substitution, which gets you that much closer. So r squared turned into x squared plus y squared. Now, if you remember, r sine theta equals y, and you should see r sine theta hidden right there. See it? That's why they put the r kind of in front. So there's your r sine theta, which turns into a y. And then from here, it's just straight up algebra. So you move plus 3y here, you have a 0. And now you have to do something called, I believe, completing the square. Right, so you're going to complete the square in order to figure out the radius. So you're going to take this term. So you see y squared plus 3y plus something's missing. So you're going to take the b term, you divide it by 2, and then you square it. So there it is.